Hello and welcome back to EASD TV, and with me another winner of the prizes, the Camillo Golgi Award, Mikael Rydén from Sweden. I'm sure I didn't say that right in Swedish.
I'll survive.
You'll survive. Thank you so much. Now, the Camillo Golgi is given for pathophysiology, prevention, and it very often is awarded to people who've stuck with a subject for many years. And actually, the thing that you've stuck with is adipose tissue. So tell me, what began your interest?
Like many journeys, it started by serendipity. I did my PhD in a completely different area of research, molecular neurobiology. And when I finished my PhD, I was adamant about the fact that I wanted to work with something that was clinically meaningful. And I hadn't.
And you are a clinician.
I'm a clinician. I'm an endocrinologist, but I wasn't at that time. I had just received my MD, so I didn't know what to go for. And I thought I was going to become a neurologist. I even thought about becoming a surgeon, which was very lucky for the patients, I think, because I'm really not a very handy man. And in the end, as always, you meet the right person, you get recruited to a group, and I ended up doing my postdoc in a lab focusing on adipose tissue in the late 90s.
And was that in Sweden?
That was in Sweden, and that's actually one of the main factors why I never, because I was aiming to go abroad for my postdoc, but I never did that. So I stuck with Sweden, and I got into this new research field, which at the time was a very, very small and nerdy field of research. If you went to a meeting, you would see everyone in the field of adipose research. So we were a couple of hundreds, globally. And that has really changed over the years. And I think that what I've done is to, stuck on white adipose tissue. I've been very interested in understanding the causal mechanisms that drive disease progression and disease development, not least, in relation to white adipose tissue.
And when was the moment that you felt that you were progressing in this field? Because sometimes you can trail away for many years and feel that you're not really getting forward in any meaningful way.
I think that what happened was that when I started in the lab, I came to a lab which was very physiological.
And where was this?
This was at the Karolinska in Stockholm. There were no advanced techniques in those days. There were no good cell models, for instance. And what I managed to do, and where I think I immediately understood that I can actually give something, is that I could employ the knowledge that I had, built up being in a preclinical research lab for many years into this more clinically oriented lab. So we could set up cell models, we set up new molecular biology techniques and so on. So I really felt that there was so much that could be done and so much that could develop the area of research. So I immediately felt that this is something I can work with for the rest of my life. So I never had that moment that I was thinking of quitting or going somewhere else.
And what was the first significant result or paper that you published?
So we had an important paper to start with. We could understand how pro-inflammatory cues could impact on adipose tissue. This was a very hot field in those days. And then through the years, we could contribute with additional papers. We used carbon-14 dating, for instance, to show that adipocytes are continuously renewed also in adult humans. We could estimate the age of lipids and understand how a dysfunctional adipose tissue leads to stale lipids, stale and old lipids, and that
the leftover fat in the chip fryer.
yeah, a little bit like that. And that's what characterizes a healthy adipose tissue, that it's very good in both taking up but also releasing the lipids, the fat, when they are needed. We've also been very interested in understanding the mechanisms controlling inflammation, where we see that the adipocytes are the ones driving inflammation. And finally, we've been very interested in understanding how fat cells are formed and how they die, and how the number and the proportion of different cell types is altered by weight changes. So I'm going to cover these mainly these three topics in my talk later today.
And absolutely, I urge you to go and look at that. You can, of course, do it online or in person if you're here in Vienna. So all of this stuff will gladden the hearts of people who are interested in physiology. But you've now begun to take this into clinical impact. Tell me a bit more about that.
Yes. So I think that, I mean, the dream of every researcher, particularly a person, working in a translational research environment like we do. We work with cell models, animal models, but also with human interventions. And one of the key findings that we've been able to present over the last couple of years is the fact that adipose tissue, human adipose tissue, is composed of several different adipocyte subtypes. And we think that how your adipose tissues is composed, the composition of these different, the proportion and the function of these different adipocyte subtypes, that determines how you respond to different interventions. So we're testing this now in interventional trials, bariatric surgery, so we follow people before and after weight loss, but also by randomized trials where we check for the effects of different glucose-lowering drugs, and how the effects of these different glucose-lowering drugs are linked to different proportions of fat cells. So we think that that's a new era of precision medicine.
Yes, I was going to say this is really precision medicine, isn't it? And does it give a physiological basis to different, to the differing drug responses that we see? So we think of, genotype being the driving force, but in actual fact, it may be cell type that's really more important.
Yes, and I think that a couple of years ago or 10 years ago, I was a bit skeptical about the single cell field that was developing across many different research areas, not only in adipose tissue. But now, in the last couple of years, I've really embraced it, and I love the fact that you get these really nerdy insights into a tissue cell composition and how one can translate that to clinical effects. I mean, these are the dream projects that I've always had a fascination to do myself, and now I'm able to do them.
So the very last person that I would think of as a nerdy scientist is you, if I may be so bold.
Okay.
I mean, you have been, of course, the scientific program director at EASD, and you've had a big influence. So you don't just focus in. I'm sure it gives you joy to focus in on your own topic, but also you're really interested in so many of the other things that impact diabetes, and we've seen that in your impact on the program. So. And just bear in mind that Tina Visbol may be listening to this.
Yes, of course.
As our current scientific director. But what do you make of this year's program, and what are you going to...
I think it's fantastic. I mean, I love the EASD. These days here they're long, intense, but they're so much worth it. And it's the place to go to. It's where you connect with friends, colleagues, new friends, new colleagues, networking, and also seeing all the interesting programs, all the new types of presentations that are launched this year. Myself giving a new thing that is called a lab talk tomorrow. So I'm not really sure exactly
So
what I would cover.
this is more gladiatorial. I'm getting the impression.
Well,
No.
I don't know. I just saw one now with Dan Drucker, which was great. But I'll do it in a different way. But I think you can. There's no set way of doing these things.
So what are you particularly marking out as must go to?
I've actually marked every day. I have a number of things to see. Unfortunately, many of them collide. So I will have to watch online. So I have
But that is the joy of EASD. You can watch online later.
That's the great thing. So I will have another week watching the interesting presentations. One thing, of course, is the cardiovascular outcome trial on Thursday morning, 7:15.
Which has been cruelly programmed at 7:15 in the morning.
That's a tough one, and I'm going to give an interview immediately after. So I have to be a good boy on Wednesday night and go to bed very early.
Anything else?
I think it's hard to pick out something that specifically stands out. I think there are so many great presentations. I think that setting together a program every year that feels engaging and novel is a major task. But I think that Tina and her team have done a great job. So I'm very proud of them.
Fantastic. But they, of course, build on an amazing foundation.
Not only me, many others.
Many people.
Yeah.
Thank you so much for being with us. It's been a pleasure. Congratulations on the Camillo Golgi Prize. And there'll be more very shortly.